Hey guys, welcome to today's lesson. If you're new here, be sure to subscribe and check out some of my other videos, and if you're already subscribed, welcome back. Today we're going to be talking about chemical formulas. We're going to look at the 3 different types of chemical formulas and how you can tell which is which. We're also going to look at molecular models. Let's get into today's lesson. If you're watching this video right now, chances are you have access to some sort of electronic device and service. Some people don't have this privilege, which is why I started this campaign, Data for Distance Learning. India has already reopened schools, but most of them are going completely online. One school in particular, Government Boys and Girls Higher Secondary School, located in the town of Poigai in Vellore, Tamil Nadu, needs your help. There are 500 students, many of which are children of weavers or daily wage workers who have been hit hard by the pandemic and aren't making much business. This means they can't pay for the data that their children need in order to attend their online classes.
நான் கவர்மெண்ட் ஸ்கூல்ல படிக்கிறேன். எங்க அப்பாவும் அம்மாவும் கூலி வேலை செய்றாங்க. அதனால எனக்கு கூலி வசதி இல்ல ஆன்லைன்ல படிக்கிறதுக்கு. அதனால உங்களால முடிஞ்ச ஹெல்ப் பண்ணுங்க. உங்க பேர்? என் பேர் கீர்த்திவாசன். அப்பா பேர் ரஞ்சித் குமார். அம்மா பேர் மாலினி.
It would cost 2,400 rupees for 1 year of data in each household. That's a little over $30 US. We want to help 100 students, which means we need to raise $3,000 in total. If you could donate even just a little and share this video with all your friends, it would make a great difference in these students' lives. The 3 types of chemical formulas are molecular formulas, empirical formulas, and the formula for ionic compounds. Both molecular and empirical formulas include the chemical symbols for the elements in the molecule. Molecular formulas tell the exact number of atoms of each element in the smallest unit of a substance. The smallest unit of oxygen can't be written as just O, because in the real world elements can only exist in pairs or more. The molecular formula for oxygen would therefore be O2. O3, although made from the exact same element, is called ozone and has different properties. O2 and O3 are allotropes, since they are distinct forms of the same element. A more complex molecular formula would be H2O2, or hydrogen peroxide, since that's the smallest unit it can be broken into while still being hydrogen peroxide. Empirical formulas, on the other hand, tell the simplest whole number ratio of the atoms of each element. That means that H2O2 would be simplified to HO. Both formulas show that hydrogen and oxygen have a 1-to-1 ratio, but the empirical formula makes it more clear. HO doesn't make up hydrogen peroxide, but that's just what the molecular formula for it simplifies to. Another example of this is N2H4, which is hydrazine. That's the molecular formula for it, since that's the smallest unit that hydrazine can be broken into and still be hydrazine. If you simplify it, you would get the empirical formula, which is NH2, although that combination wouldn't actually be hydrazine. Some elements have the same molecular and empirical formulas, the most common example being H2O, or water. H2O is the smallest unit of water, but it can't be simplified further, so it's both the molecular and empirical formula. Ionic compounds usually fit into this category. I'll get into why that is in a minute. Arjun, what are you doing with my modeling clay? You're not supposed to play with it.
But I'm making stick men.
I would ask why, but I'm pretty sure you don't even have a reason.
Actually, I do. I'm making them so I can have friends that never leave me.
That's depressing.
What'd you say?
Nothing. You just reminded me, though. I'm gonna need that for my video.
Sure.
There are multiple ways to visually represent a molecule. Let's practice with a really hard example, because once you get the hang of it, it'll be easy to do other simpler examples. Let's look at methanol, which is written as CH4O, or CH3OH. The reason why it can be written the second way is because OH is a group, so the other 3 hydrogens attached to the carbon. The structural formula for this would be written in the way the atoms are connected. So here we would have a carbon atom with 3 hydrogens directly attached to it, and that is attached to an oxygen and hydrogen group. The ball and stick model is essentially a physical version of the structural formula, with the atoms being represented as different colored balls and the bonds being shown between them. This is a good way to show the atoms clearly, but the balls aren't proportional to the actual sizes of the atoms, and the sticks exaggerate the spaces between the atoms. The space-filling model doesn't show the bonds. Instead, the atoms are all joined together. This is more accurate to how the atoms are bonded, and the proportions of the atoms are accurate too. But they're hard to make and they don't show the 3D positions of the atoms very well. You should choose which model to use based on the molecule. It differs for each one. Now back to ionic compounds. Ionic compounds are made up of cations and anions. If you don't know what those are, watch my previous video, Molecules and Ions. These cations and anions combine so that the compound is neutral. Since the only goal is to be neutral, the cations and anions usually end up combining in the smallest and simplest ratios. Because of this, they usually have a molecular formula that can't be simplified further, and is therefore the exact same as its empirical formula. Let's review what we learned today. There are 3 types of chemical formulas: molecular formulas, empirical formulas, and the formula for ionic compounds. Molecular formulas and empirical formulas include this chemical symbol for each element in that molecule. Molecular formulas also have to be in pairs or more, which is why O isn't considered a molecular formula, but O2 is. Molecular formulas also give the exact number of each atom for each element in that molecule, while empirical formulas only give the ratio of the atoms. There's a group of molecules that have the same molecular and empirical formula. Some molecules that fall in this group are ionic compounds. Ionic compounds are made up of anions and cations that combine just enough to make a neutral compound. Because of this, they're usually already in their simplest form, so most of the time their molecular formula is the exact same as their empirical formula. Finally, let's talk about molecular models. The stick and ball model gives a clear visual as to how the atoms are bonded. But the atoms are not proportional and the stick bonds are over-exaggerated. The space-filling model gives an accurate representation of how the atoms are bonded and the atoms are proportional, but it can be hard to make and to understand. The question of the day is, what is the name for differing forms of an element? Write your answer in the comments below. Please like, share, comment, and subscribe for more videos every week.